Alright, so today we're going to look at something called undetermined coefficients, or the superposition approach. So to solve a non-homogeneous linear differential equation, we must do two things. So number one, find a complementary function, and number two, find any particular solution of the non-homogeneous equation. The general solution would be the combination of those two solution types, where the complementary function is a general solution to the associated homogeneous differential equation. All right, the first of two ways we're going to consider for obtaining a particular solution for a non-homogeneous linear differential equation is called the method of undetermined coefficients. General method is limited to linear differential equations where the coefficients are constants and g of x is a constant k, a polynomial function, an exponential function, or a sine or cosine function, or finite sums or products of these functions. In other words, like every other thing we've seen so far in this course, this is only going to work if certain conditions are met, and it's specifically if the g of x function, so the thing on the left or the right side, fits one of those general formats. So polynomial, e, sine, cosine, specifically, and then we can use this approach. So let's walk through. Let's look at one. Okay, so our first part is to focus on the left side. So we're gonna ignore the right. We're just going to focus on solving this guy. So y double prime plus 4y prime minus 2y equals 0. Good news is we've seen that. That's converted to an auxiliary equation. So m squared plus 4m minus 2 equals 0. Factor that, and then based on the solutions we get, we know what the general format of the equations are going to look like. So that would be like m and m. Ooh, it is not factorable. Okay, scratch that. We're going to do quadratic formula here. So m equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So that's going to give me negative 4 plus or minus 16 plus 8. So 16 plus 8 is 24 over 2. Just negative 4 plus or minus. We can take a 4 times 6, so 2 square root 6 over 2. So negative 2 plus or minus square root 6. Okay. All right, so that said, that means our general format, so our complementary equation solution then would be C1 e to the, let's see, negative, I'm going to put that all in parentheses. So negative 2 plus square root 6 x plus c2 e to the negative 2 minus square root 6 x. Okay, so now we're going to focus on the right side. So the 2x squared minus 3x plus 6, that's our g of x. So I'll write that down real quick. Doesn't hurt to do that. So g of x is going to equal 2x squared minus 3x plus 6. And the assumption we're going to make is the solution of our equation that fits in that format. So our particular solution, it should be something quadratic. So ax squared minus 3x, I'm sorry, ax squared plus bx plus c, so in general. And then our, we're going to look at derivatives. We're going to bring up the this side of it, right? So we're going to make a connection, so I need a y, so I got an equation for y. I need an equation for y prime. So that's 2ax plus b. And then I need a double. So that would be 2a plus b. Okay, so then I want to take those three expressions and evaluate it into the y double prime plus 4y prime minus 2y. So this part right here. Okay, so 2a plus b plus 4, and then, oh yeah, that's right. Okay, so then 4 times 2ax plus b minus 2, and that's ax squared plus bx plus c. Okay, so we're going to clean that up a little bit, and again, we're connecting that. All of this has to be equivalent to 2, the original differential, 2x squared minus 3x plus 6. All right, so let's gather up all of our like terms. So we have 2a, and if I gather up all my x's, so that'd be 8ax plus 4b minus 2ax squared minus 2bx minus 2c. And let's put this in order by degree. So lining up all the x squared, so we get negative 2ax squared. And then I have an 8a and a minus 2b in terms of x, so I'm going to group those together. So 8a minus 2bx, and then for the constant, I have 2a plus 4b minus 2c. And all of this is going to be equivalent to that 2x squared minus 3x plus 6. And you're going to see I'm kind of grouping them up in things that should be connected together. And then going forward, I'm going to use that. So, negative 2a, I'm going to highlight this. So negative 2a has to equal positive 2. And 8a minus 2b has to be equal to negative 3. And 2a plus 4b plus minus 2c has to equal positive 6. So that's going to give me 3 different equations that I can go back and solve. So, all right, so I've kind of copied this over so I got a little bit of space to work here. So a has to be negative 1. Then this would be 8 times negative 1 minus 2b equals negative 3. So that's negative 2b equals, let's see, negative 3 plus 8, so 5. So that means b has got to be equal to negative 5 halves. And then the last one would be 2 times negative 1 plus 4 times negative 5 halves minus 2c equals 6. So that's negative 2. That would be 4 divided by 2 is 2, so minus 10. Minus 2c equals 6. So that's negative 2c equals 6 plus 12. So 6 plus 12 is 18. So that means c has to be negative 9. Okay, so let's put all that together. So our particular solution would be negative x squared minus 5 halves x minus 9. So our general solution then would be to put those two parts together. So the complementary and the particular. So that would be C1 e to the negative 2 plus square root of 6x plus C2 e to the negative 2 minus square root of 6x, and then the other piece that we just found out. So minus x squared minus 5/2 x minus 9. Yay!